This is part 3 of the Craftsman Emerson 150 drill press rebuild series. If you haven't seen part 2, click the link at the top of the screen. In this video, we will be disassembling the motor and then cleaning parts. Hello everyone, I'm Jeff and welcome to my shop. We got a lot to cover, so let's get to it. So the first thing we're going to be doing is testing this motor, and I already know it runs, but I just want to film it for you guys. You can see that there is a break in the power cable there, right at the bend of the table. So we've got the plug strip turned off and the motor turned off. Now we turn the motor on, turn the plug strip on, motor powers up. Then we'll turn it off and listen for the click of the governor disengaging. And we are good to hook. So let's get this thing apart. First thing we're going to be removing is that pulley that's on the shaft there. And it's got a set screw that locks it in place. We'll just remove the set screw. I think that's a 4-inch pulley for a 1/2-inch belt. But we're not going to be reusing it on this rebuild anyways. So it's kind of rusted on there. We will apply some PB Blaster. And I'm using a different microphone now, so I'm hoping that this audio is going to come out okay. My previous microphone is USB fed, and it was having some issues if you didn't notice on the last 2 videos. So hopefully this microphone will work better. So we're going to use a 2-prong puller to pull the pulley off of the rotor shaft. And it should come right off of there. Like that. Make sure we didn't bend the sheaves on that. So here we are at the bottom of the motor, and we're going to remove the capacitor cover. So this just has 2 screws in it. And unlike the drill press, most of these screws are going to come out okay. I think we're going to have 2 of them that give us a little bit of trouble with the air cone, but for the most part, all these screws come out okay. So this is the sardine can capacitor. It's in its original cardboard box, which is a insulator. And it's kind of sticking in there a little bit. Had to help it out of there. So as I do for everything that I disassemble, I mark everything. So I'm marking all of these wires where they're coming from. And I even marked the capacitor itself, even though I don't think it's a polarized capacitor. Next, we've got the power cable. So all of these wires are very brittle. They are stiff and brittle. So we're just going to chop off the power cable and then start cutting those connections. And then we'll mark all of that properly. Next, we're going to remove the on-off switch. So we're just using a wrench to undo the nut that's on the outside. Once we've got that spun off, we can push the switch through the base, remove the plate, and then mark the switch and cut the wires for it and mark all of those. Go back and mark those 2 wires from the power. And next we can remove the base. But before we do, we're going to remove the grommet that's there. We'll be replacing that. So I'm just pushing it through with a screwdriver. And there it goes. So we've got these two screws that mount the base to the stator. And we'll just remove both of those screws, and then the base slides right off of there. Next we have the stator band, and basically the two ends are kind of folded over on each other. So I'm just using a screwdriver to bend them up and slide them, and then we can slide the stator band right off of there. We'll be removing that motor data panel from the stator band a little bit later. Next we have the terminal bar and all of the wire connections there. So we're removing the terminal cover, and then we're removing each one of these connections. Again, all of these wires are very brittle and they're very stiff. So as I remove them, I'm marking where they are on the terminal bar, and I'm going to be putting together a kind of a wiring diagram like I've done on previous videos, and I'll attach it to the video when we get to assembly so you guys can see where all this is supposed to be connecting. But on the terminal bar, each one of the terminals there are marked. They're numbered. So that's what I'm actually putting on those pieces of tape so I know where they go. Then we have the felt cover. It has 4 screws on it. And then we can remove the felt, and then the end plate, and then the gasket. And that is the order that they go in up top there. Now this is the other end of the motor, and it's basically the exact same thing, except there is a spring washer. You can see it there, and that's the order they go in. Done deal. So now we can remove the long screws, and these have acorn nuts on each end. There are 4 of them. And I don't know if you guys can hear it, but my dog is barking in the background. So now that we have the 4 long screws out, we can remove the other end frame. And I'm just going to use that 2-prong puller again. I got this off of Amazon years ago. It's been absolutely awesome. Worth every damn penny I paid for it. So here we are with the other end, and there's the air cone, and these are the 2 screws that actually gave me trouble. So rather than messing around, we'll crank out the blue wrench and heat that shit up. Yep, they'll come out no problem now. And there's your air cone. And that completes that side's disassembly. So here we are with that bearing for the other end, and we're just going to use that 2-prong puller again to remove the bearing. Now notice that the side that's facing us is open and the other side is shielded. That's because these are felt bearings. They're designed for the felt that we removed earlier to help lubricate the bearings there. And when we reassemble this thing, you don't have to have open bearings. You can have sealed or shielded bearings for this motor. It's just the way that they designed it back in the day. So here we are using the prong puller again to remove the end frame on the terminal side. And now that we've disengaged it from the stator, I want to try to get that rotor out of there. So we'll try to drive the shaft through the bearing like so. Now that the rotor is out, remember these wires are very stiff. We don't want to break them. We're probably going to go back and replace most of them anyways, but I want to do the least amount of damage possible. So we're going to remove the terminal bar, the switch assembly, and the overload protector, which would be a total of 6 screws, 2 for each. After we got the screws out, then we can remove the parts. We have the terminal bar, and then parts of the switch assembly is the shield, the insulator, which is the black piece, and then that's the overload protector, and then the switch itself. And that's the order they go in. So we can set the stator to the side, and then we need to remove the bearing from this end frame. And we also, oh, look, there's always one paper insulator. Have no idea where the others went. So we're just going to use a socket and a mallet to tap that bearing out. It needs to go from the inside outward. There's a little lip that it rests on, so it cannot go all the way through. The other end, it can go all the way through. Then we're just going to use a small punch to drive out these 2 drive screws that are holding the overload protector plate on the other side. There it is. And I think it just says something like push to reset or whatever, but here we are with the rotor, and we're going to disassemble the governor. So there are 2 springs, and you just unhook one end of the spring and then unhook the other end. Sometimes these springs can be broken. You can find replacements for them. Then I'm going to bend the arms a little bit to get the 2 governors out. And then we've got the plastic sleeve, the spring. There's a metal cup washer type part. And then a paper insulator. Like so. And that is that. So we've got the stator band, and we need to remove that motor data panel from the stator band. I'm just going to drill out these rivets that are holding it on. And I'm playing with a couple of different sizes of drill bits to be able to get that off of there without damaging it too much. But I eventually am able to get it off of there. We're going to attempt to reuse this stator band, but you can see under that motor data panel what the stator band was supposed to look like. So next we're going to soak just about everything in simple green for 24 hours. So certainly all of the regular parts, the steel parts, but we can soak the Zamic parts as well as the chromed parts. The only things that won't go in the simple green are any of the electronic parts that have wires on them, like the switch and the stator, and anything that has graphics. So the headband, the data panels, all of those items will not go in the simple green, but the stator band itself will go in the simple green as long as you removed the motor data panel on it. Also, none of the paper or rubber parts will go inside the simple green. And the simple green degreases over time, but it also can remove paint, and that's why we're not putting any of the panels in there, because it will strip them of all of their graphics. So primarily I use it as a pre-stripper of paint and a degreaser. And it helps break up the dirt daubers and all that kind of junk that's on there as well. So here we have the column, and I have a 4-inch piece of PVC pipe that's capped on one end, and I'm just going to slide the column into that pipe. And be careful not to bust the cap off the end. And we'll stand that up. And we're going to strap it to that post from my deck. If it doesn't fall over. I don't know why I didn't speed this footage up, but I didn't. In any case, once we get it strapped down, then we're just going to pour one of those simple green jugs into the top of it. And that's really all it takes, is just one of those. I think they're 2.5 gallons each. So whatever their capacity is, that's how much fits inside that column. And then we're going to let all of this stuff soak for 24 hours. If I haven't mentioned it before, I like playing with the DaVinci Resolve program that I use to edit all these videos. So in any case, reclaiming the simple green is fairly simple. I've got this little battery-powered siphon that I got from Harbor Freight, and I'm using a paint mesh filter. They're disposable, in a strainer or in a funnel, and then we're just filling up those jugs. And I'll do this for all of the simple green except for about 1/2 gallon that I leave in the bin because it's too dirty to reclaim. Next, we'll remove the simple green from, oh, there's my dog making a cameo, from the PVC pipe. And then we'll filter that simple green out of that 5-gallon bucket off camera. We're just going to rinse the column off, and I've already rinsed and cleaned out the PVC pipe. So once we've got the column rinsed, we're just going to put it back in the PVC pipe and restrap it where it was, because we'll be soaking it in citric acid next. And if you build one of these, just don't let that pipe slide all the way through there, because it will bust that end cap right off of there. So, like I said, we'll just strap it back down, and then we'll mix up that citric acid and add it later on. So here we are with the parts coming out of the simple green. And you can see there's still paint, this gray paint that's on the end frames for the motor. And I'm just using a wire brush, and then as I scrub it with the wire brush, that paint just sloths right off of there. And that's one of the great things about the simple green, is it just breaks down that bond between the paint and the metal. Not always, but about 60 to 70% of the time. Makes the paint come right off of there. So this is just some speeded up footage of all of the parts that I'm pulling out of the simple green and hitting them with the wire brush, or at least most of them, and rinsing all of them off. So for the citric acid, there are a couple of parts that we're not going to be putting into the citric acid. So again, we're not going to put any of the electronic parts or any of the parts that have graphics on them in the citric acid, but we're also not going to put any of the Zamic parts in there. So for the citric acid soak, this is citric acid. You can get it off of Amazon all day long. It comes in various sizes. I think that's a 5-pound bag. It was like 30, 40 bucks. I've got a little scooper. It's like a tablespoon scooper, and I mix about a tablespoon per gallon of water. And then we'll agitate it with the water and get it all mixed up really well, and then start putting parts in this bin. So of the Zamic parts, we're talking about anything that was chrome plated, as well as the pulleys. So those are the Zamic parts. And there were a couple of Zamic parts that were on the rotor assembly as well. The two governors, those are Zamic. And if you don't know what's steel and what's not steel, you can always put a magnet on something. And if the magnet doesn't stick, if it's non-ferrous, then do not put it inside the citric acid. It's not going to destroy it. It's not going to melt it, but it develops this weird film if it's in citric acid for more than, say, an hour. The steel parts and the cast iron parts, you can leave them in citric acid for a week. I mean, it's not going to hurt them. The only thing the citric acid does is it removes the rust, or at least some of the rust. Now, for most drill press rebuilds that I do, this is usually enough to remove most of the rust. But in the case of this drill press, we're going to have to come back in the next video and really hit some of these parts with wire wheels. But here we are mixing up the citric acid for the column. We'll just pour that bucket of citric acid into the pipe for the column. And we will let all of that stuff soak in the citric acid for about 24 hours. And that's going to wrap up this video. I hope you enjoyed it. If you did, please like and subscribe. If you got any questions, leave them in the comments section below. I will answer them as soon as I possibly can. I really appreciate the support. And as always, I will see you next time.